Hey everybody. Well, while I'm waiting to get some more material for the video I'm currently working on, I thought we would stop that for a little bit and work on this one. Kind of getting the urge to work on another piece of audio gear here, so I thought this would satisfy my urge to do so. This is a Kenwood model KA-9100, and it was purchased again by my good friend Dave, who is really the driving force behind this channel because, you know, we have kind of a symbiotic relationship. I love working on these types of audio gear, and he loves collecting them, and he loves the storylines behind them and everything. So do I, really. And so, you know, he always seems to find some really cool stuff. This is one of them. I don't know anything about this thing right now. And if I recall, I think the story was that this does not work and it will need to be troubleshot and repaired, but I'm not sure. We're going to find out. Cosmetically, it doesn't look too bad. There's a little tiny bit of surface corrosion. You can see right here, and on the bottom cover, there's a little bit like this as well. And there's a little boo-boo right here. And I do not think that happened in shipping. I think that that was there from before. So, nice looking receiver. It's strange, but it appears as though this is right around 100 watts per channel, maybe. Or I'm not even sure what we'll have to look up the specs of a KA-9100. I do know it weighs an absolute ton. It has dual power supplies. It has a separate transformer and power supply for each channel. So one transformer for the left, one for the right. And big, huge heat sinks. I love to see those, you know, for all that Class A, B goodness. And it should be pretty exciting to find out how this sounds. Now, a good friend of mine growing up that I grew up with, he had the smaller model of one of these. His was rated, I think, at 40 watts per channel, if I recall correctly, but it looked very similar to this one. It's from the same era. He also had the matching tuner that went along with it and had a really nice set of Kenwood speakers with the 12-inch woofers. They were three-way floor speakers. Really nice sounding system. So I'm pretty jazzed about hearing this thing fire up and kind of hearing that sound once again. So let's get started and just see where we are, see what it does or doesn't do. Okay, I have my Buzzy isolation transformer power supply turned on, and I really do need to remove that transformer and relocate it across the room and put it on the floor or something so we don't hear the buzziness. Yeah, that's that and another million things to do. So I have removed the pipe cleaner, and I have the current limiting bulb set up over here. Move some of this stuff out of the way. I have so many projects sitting in the queue right now you just wouldn't believe. So, all right. Okay. Let us see what happens. Well, that's a good thing. The bulb flashed and then went totally dim, and it charged up. But I don't hear the protect relay coming out. So, I should say coming in. Yeah. Now, I don't know if this even has a protect relay as per se. I don't know. I've not even looked at the schematics or anything on this, but one thing I can tell you is the speaker, the power meters don't, usually when you turn these on, sometimes you'll see the power meters will just pop a little bit. You can see we're not getting that. And if I turn it off, wait about 10 seconds or so for the capacitors to bleed down, that should be good right there. And I turn it on, you can see the the light will flash and then go dim. And the longer I wait, the more it'll discharge and the brighter that'll flash when it comes on. So it tells me the power supply, at least one of them, seems to be alive. Okay, let's have a look at this schematic. I have the bigger pages too, but this, we can see what we need here. So that chip, which is a KA-9100WA, it appears that pin 7 of the board or pin 5 of the chip is going to be the output. So if we have any kind of crazy DC offset, it would be there, either there or on the other side, right power amp board. So we'll have to look at that. And it appears that pin 8, looks like pin 8 is the output of the other side. So we're going to have to look at that, and I think I'm just going to try to go for the chip because I think I can get down in there and look at it. Of course, there's their test points there, so I think we can just look at the test point. Test point 7, that would be right there, and test point 8 would probably be on the other side, which is right there. So yeah, so I should be able to look there and see if we have DC offset. I think that's going to be our quickest way out. If I see crazy DC on there, then well, we're pretty much wasting our time on everything else, huh? So let's turn that on. Turn this on. It would help if it was plugged in. Okay. Ground is ground all around. Let's see, pin 8. Nothing there. Okay, so how about over here, pin 7? Nothing there. So obviously there's no offset. And again, two separate power supplies. You can see the two transformers, but they do share a common protect circuit, and you can see this is it right here. If I get it in the light, and there's the little LED on the front, which I don't know if light on means protect. I'm assuming it does. And if you notice, it never went out. It stayed on the whole time. So this thing's staying in protect for some reason. Let's look at some other things. Let's check some of the voltages, the B plus and B minus. So for instance, we can look at 6 and 12. So let's see what 6 and 12 look like. All right. So here is pin 6. Is this 6? Yeah. 55 volts, and pin 12, I'm not getting good contact, minus 55. So that's good, 6 and 12. So we have power, but we don't have any DC offset, right? So that would kind of, and you know, I have 58 millivolts, so that's kind of telling me that this thing's happy over here. And let's look at this side. Okay, so on this side, the B plus is going to be, B plus and B minus is going to be 13 and 8. So pin 8 is going to be the plus, or no, what did I say, 13 and 8? Goofy. 12 and 6. That's what we want, 12 and 6. So let's go here, and let's go, it can't be right. Am I getting ahead of myself here? Let's see. Oh, I'm sorry, 5 and 11. 5 and 11. So there's 5. Aha! No voltage. Pin 11. No voltage. Do you see that? 5 and 11, there's nothing. So maybe we have just something dumb like a blown fuse, which, why didn't I check that first? You know, it wouldn't have mattered because they all appear to be intact. Well, no, maybe this one's open. All right, let's shut it off. Let's unplug it. And I'm going to wait for it to bleed down a little bit. And then we're going to pop these fuses and check them real quick. Okay, and you didn't see what I was talking about, did you? So here's two of them here. There's the other two down there, if you can see them. Okay, so let's check those. So F2, F3, and F4 are all good, but F1, which is this one right down in here, is caca. Look at that. Now, I'm not just going to go and replace the fuse. We're going to try to find out why said fuse blew. And looking up here, so there's F1 and F2. And that's on one side. And then, let's see what we have here. I don't see the fuses going to the other power supply here, but I'm sure it's in there someplace. And I'm seeing 4 other fuses. Okay, so I have 2 fuses here and 4 fuses here. So 5, 6, 3, and 4. So 3, 4, 5, and 6 are here. 1 and 2 are there. Do I even have the correct schematic? KA-9100. That should be it. This does not look exactly the same, but I might be looking at it incorrectly. So let me check around a little bit here and make sure that I'm not crazy, because, you know, quite often I am. Well, that's interesting. After a little bit of research here, a little bit of reading, first of all, 5 and 6 are not used on this amplifier, and this must be for the 240 volt model. None of these fuses are for the power supplies. So, well, they are, but so 3 and 4 are the 120 volt mains fuses for the 2 power transformers. F1 and F2 come off of the 30 volt windings of those transformers and feeds into this, and this bridge rectifier is what controls your low voltage power supply. This is really interesting, and everything is like mixed up on the boards. Now, one power supply for one channel goes over to the diode board, and you can see 2 filter capacitors and the bridge rectifier, and these leads go on up and they go to this transformer up here. The other channel, the wires from that come down and go here, and they go into the diode / relay board, and there's your capacitors and your bridge rectifier for the other channel. And on this board they also have the speaker protect circuit, but they do not have the protect relay. They show that over here on the power supply board. So part of your protect circuit is here, but the relays for the protect circuit are here, and your low voltage power supply that's regulated supply is here. So you have several boards with the circuits kind of scattered all over it. And if F1 is the one that's blown, which is this one here, that's coming off of the AC 30 volts from this top transformer up here. That means that more than likely either your positive or negative low voltage supply has a problem. So I think what we're going to need to do is we're going to need to pull this low voltage board to look at it a little more closely and see if there's anything wrong here. I really don't want to put a fuse in here unless we know for a fact that nothing is dead shorted. I don't want to cause any additional damage. And what we might do is we may disconnect these couple of wires that go out to the outside world, because these are your power supplies. This is B plus and B minus. You see them? Pins 23 and 25. And 24 appears to be your ground, or your common point. So what we're going to do is we're going to pull those two wires off. I think might be a good start. We're going to just ring out these transistors. If they're good, we'll put a fuse in it, see if we can power it up with, without these being connected, and see if we get voltage there. I'm just trying to go slow and not cause any more damage. The last thing I want to do is damage these chips. Okay, the wires are disconnected. Hopefully nothing's shorting out. I'm going to turn this on. And I don't know what our fuse did, but I did put a new fuse in there. And let's go from here to here. I have nothing, so it tells me I just blew my fuse. So I probably won't make that mistake again. Yep, nothing. So it just probably cremated that fuse again. So we have a problem on this board because our power supply is disconnected there. So, well, cost me a fuse, which I hate because fuses are expensive now, but now we know. I probably could have put something in line with that, like a little lamp or something, but that's all right. So let's start troubleshooting. There's not much to this board, so we're going to find the problem one way or the other. Oh, and by the way, measuring either of these wires to ground statically, it's way up. It's kind of reading either a capacitor or, high ohms, very, very, very high ohms. And reading from either one of these pads to ground, again, very, very high ohms. So I don't think there's a short there. It's going to be somewhere prior to that. And most likely one of the transistors or one of the capacitors is shot. Okay, let's just stop right here and back up for a minute. Kind of in the process of making a video, I've kind of got sidetracked from the fact that I'm also troubleshooting this problem. So what did I do wrong here? Okay, so the first thing we did was we measured, if you recall, I measured the B plus voltage for this amplifier and this amplifier for the right and left channels. And we had plus and minus, B plus and B minus on this side and no B plus and B minus in the other. So we looked at the fuses on this regulated power supply board, and without actually getting a schematic first, found that fuse F1 was popped. We then printed out a schematic, and I looked and found that it was over here, which is your AC 30 volts. So this is feeding your regulated power supply. Well, that's all well and good. We started chasing the problem on the regulated power supply, but the problem with that is, if you notice, this board really doesn't use the regulated power supply. It is just using the plus and minus 55 volts. So what we did was we got sidetracked here, right? That's what I did. And so even though this is another problem that I've identified, still an entire power supply is out. So either this side or this side. So I think before I continue troubleshooting the regulated supply, I really need to take a look and see if both of these transformers are working properly and why there is no power. The B plus is missing from one of these channels. It does concern me that we have all that, corrosion there, or whatever, the paint modeling on those transformers. Did they overheat, and did one of them actually fail? Because if there's a bad power transformer in this thing, that's kind of game over right now until we can find another transformer. So I think that really needs to be the course of action, and we'll come back to this regulated low voltage supply afterwards. Okay, let's look at the schematic. So the input of the two transformers here, you have the red wires. If you notice, they're tied together. Let's get that out of the way. So red wires are tied together here and here. And yes, I'm holding the schematic up and it's shaking a little bit, so have to live with it. White wires are separate though. They're not tied together between the two transformers. You have one of them going through one fuse and the other one going through the other fuse. So what I did was I popped these two fuses out. So now they're no longer tied together. And that allows us to check across each coil, you know, each transformer's primary individually. So I'm connected to the red wire, which are the two that are tied common together, which is right there. See the red? And the other lead here, here's our two white wires. There's one here and then the one above it. And I'm set to ohms. And hopefully you can see everything. So if I go to this first one, I have about 2.5 ohms. I would say that's okay for the primary. Uh-oh. And for this transformer, we have open circuit. We have a bad transformer. Bad power transformer. So right there, this amplifier is game over. So yeah, I put about half an hour into troubleshooting this and kind of wasted about 10 or 15 minutes getting sidetracked on the low voltage supply, you know, the regulated supply. And again, the fuses, strangely enough, are not blown. It just looks like the transformer shorted and overheated. Now, let's see if this is the one that has the most paint worn off of it or melted off of it. Actually, when you look at it, this one here looks far worse. You see it? This is the one that's testing good. That'll be the top wire. Yeah, that's strange, but this one's actually still testing good. This one tests open. So unless we can find ourselves another power transformer for this, this thing is going to become a parts unit, because without the transformer, the rest of the amp is pretty useless. Okay, the bad news just keeps coming. So what we have is I've disconnected the power wires from the amplifier module that's on the side that has the bad transformer. So that would be this module up here. There's two modules, of course, right and left channel. Our left channel is the one that's got the problems. And there's only 1, 2, 3, 4, 5, 6 connections on the entire board. You have 2 grounds, you know, for your input and output. You have your input signal, and you have your output signal, and then B plus, B minus. So really, all I need to do is disconnect B plus, B minus, and connect those to an external power supply, and I should be able to power this whole module up and see if we get any kind of DC offset or anything at the output. If it comes up, then what we can do, what we would be able to do is put a signal in here to see if it passes the signal. Here's where the ugliness starts. I've done that. Here is the plus, B plus, and B minus. And I have a split power supply that you can see over here. And it only goes up to 30 volts instead of 55. But you can see it right here. And I have it in differential mode, so it'll do a plus and minus power supply. And that goes in here. And then we have the ground lead. And then we have our meter connected to this yellow wire, which would be the speaker terminal. It goes down to the output of that power pack module. Now watch what happens as I turn up the voltage. Yeah, That's at the speaker terminals, or would be. So you can see the further up I go, the more it does this, and eventually it starts to draw current. And, well, that tells me that most likely the Darlington power pack module is faulty. Now, there's a very slim possibility that one of the small signal transistors is shorted, but I would say if that's the case, it's probably damaged the chip as well. So that KA-9100WA power pack module is also bad. Now, chicken or the egg? You know, did that power module take out the transformer? How could that have happened? I mean, the primary of the transformer is open. And I've verified that, no doubt. If the primary of the transformer is open, that means it would have had to have drawn enough excessive current to take out that winding. But there's a fuse right in line with that, and the fuse in there was good, and it was the correct value, which is only like a 1 amp fuse. It's not a very large fuse. Actually, it's a 2.5 amp fuse. So you would think that the fuse would have blown before the transformer fried. The only thing I could figure is at some point in time, somebody replaced it with an incorrect fuse value. Now, something that I found that was kind of strange, if you look way inside there, I don't know if I can zoom you in close enough, but you see down there, there's the fuses. I have the ends of them pulled out. But look at the fuse terminals, how terribly tarnished they are. And again, that could be a sign of heat, or it could just be that the type of metal they used was crap. Either way, I do have those new little clips I can replace. And this is turning into an absolute parts amplifier, typically what you would do with it. That being said, I'm going to continue testing it a little bit. There are workarounds for this. I actually found online a toroidal transformer that not only has the two, instead of 43 volt, it has 45 volt winding. So there's a 2 volt difference. That might be a problem if the chips can't handle it, but I think they can. And I also found a company called Pyramid Audio, and I have used their kits before. They specialize in building replacement discrete component modules to replace the STK, chips by Sanyo, and the Sanken chips, and these Trio modules. And they have one specifically designed for the TA-100WA. And so I can order a pair of those, and I can order a pair of those toroidal transformers. By the way, they are much, much heavier duty than these. And being toroid transformers, they're pretty much better in every way. But the really crazy thing is, not only did it have the two 45 volt windings for the power amp, it had two 15 volt windings for the low voltage supply that we could wire in series and get our 30 volts. So it's a drop-in replacement. I will have to make a different mounting bracket for the transformers. But if I decide to do this, and I go ahead and do it, we can actually rebuild this thing and actually make it a very special amplifier, make it way better than it was before. So I'm going to think about it, because what's going to end up happening is, if I do this, I'm going to end up spending more money on this than this amplifier is worth. Maybe someone who really would know, understand, and appreciate what this is, if it works the way I'm thinking, might pay enough for me to get my money back out of it. But I don't know. It might end up being just a special project that sits on Tony's shelf. Or maybe sits on my stereo rack. I don't know. But I think I'm going to wrap this video up for right now. And I'm going to think about it a little bit. And I may go ahead and order those two transformers and two of those modules, which is probably going to be about a $300 plus investment. by the time I buy those 4 items. Because, of course, whatever I do to the one channel, I want to do to the other channel because I want them to match. I could definitely just rebuild the one channel, but I'm not going to do that. If I'm going to do it, I'm going to go all in. Of course, the thing's going to need recap, all the capacitors, and you can see all the things stuffed up in there. But that's all small potatoes. We can fix that. Essentially, if we have a good power supply and we have a good power amplifier module, everything else is fixable. There's nothing else in here we can't make perfect. So, I'm going to wrap this one up. I'm going to get this video posted up there. And let me know in the comments what you think. I'm sure some of you are going to say, Tony, you're crazy. And, well, you're right. I am. Some of you might say, gee, let's do it. I want to see it. I want to. Yeah, I bet you do. You're not paying for it. Oh, I'm just kidding with you guys. But let me know your thoughts. I think this is a really cool amplifier, and I do think it will work very well. And reading on the Audio Karma website, there's quite a few threads involving this amplifier, these modules, different things like that. And there's mixed bags of comments, you see. Some people don't like them because of the unreliability of those chips, but other people think this is a great sounding amplifier when it's working. And very well built like a tank. I mean, it's so, everything's just absolutely overbuilt as far as, structural integrity is concerned. So, I don't know. I think, I don't know. I'm almost convinced I'm going to do it, but let me know what you think. Until then, peace, joy, happiness, and good health to all of you. And, well, you're either going to see the continuation of this project, or you'll see another project go up on the bench, or hopefully I'll have the materials I need to finish my computer-y type video. All right, take care. Bye-bye.